is Yunona, and today I will be discussing the Monty Hall paradox. The Monty Hall paradox comes from a 20th century game show called Let's Make a Deal. The game show host was named Monty Hall. This problem concerns what is done during the game. First, during the game, a player comes up onto the stage. On the stage are 3 curtains. Behind 2 of them is hidden a goat. Behind 1, a car. The player's objective is choosing the car. First, the player chooses a curtain. He doesn't know what is in any of the curtains. Then, from the remaining 2 curtains, the game show host, Monty Hall, reveals a goat. The player then has the choice. He can either stay on the curtain that he originally chose or switch. The curtain that he ends up choosing, it will be revealed, and the player will get what is hidden, what is behind the curtain. The player's objective, like previously said, is to obtain the car. Now our question is, should the player switch? Let's call the curtains A, B, and C. Now let's say that the player chose curtain A. He does not know what is behind that curtain. Now let's say that the car is C. Goat number 1 is a red G. And goat number 2 is a green G. So now, let's say that the player chose curtain A. He does not know what is behind that curtain, like I already said. It could be either C, red G, or green G. Now, the probability of it being C is 1/3, because it can be any of these 3. The probability that there is a red that there is goat number 1 behind curtain A is also 1/3. And the probability that there is a goat number 2 behind the curtain A is also 1/3. So, if what is behind the curtain is a car, then the game show host can choose between 2 goats to reveal. Because there is 1 car and 2 goats, that means that there's 2 goats left. And the game show host needs to randomly choose one of them to reveal to the player. So, he can choose from the red goat and the green goat. Now, if what is behind curtain A is a red goat, then what's left behind the other 2 curtains is a car and the green goat. So, the game show host cannot reveal a car. That means that his only choice is to reveal the green goat. And finally, if a green goat is behind curtain A, then what's left is the red goat and the car. Since, like said before, the host cannot reveal a car, he can only reveal the red goat. Now let's list all our possibilities. hides a car, then the first possibility is that the host chooses the red goat to reveal. That happens with probability 1/2 because you can choose between the two goats. And so the probability that the red one will come up is 1/2 between the red one and the green one. Then, let's say that curtain A hides a car, but the host decides to reveal the green goat. Now that also happens with probability 1/2 because it's randomly chosen from the two goats. Now, let's say that curtain A is hiding a red goat. Then, our only choice is to reveal a green goat because that's the only other goat. And that happens with probability 1 because we have no other choices of goats. Now, if curtain A is hiding a green goat, then our only choice is for the host to reveal a red goat because there are no other goats, just like in the previous possibility. So that happens with probability 1. Now, our question is, should we switch? So maybe we should look at, for each of these possibilities, what will happen if we switch? Now, the second letter is what the host reveals. So that's what we know. We can choose to switch between this letter, the first letter, and the remaining letter. So for example, in the first possibility, curtain A is hiding a car. The host reveals the red goat. So what's left? The green goat. So now, since the player chose the car, although he doesn't know it, if he switches, he'll get the green goat. And we don't want that because the player wants a car, not any of the goats. So, if he switches here, he loses because he gets the green goat. Now, let's look at the second possibility. Here, curtain A is hiding a car. That's what the player chose. After the player chose, the host revealed the green goat. So what is left is the red goat. Now, so then the player has a choice. He can either stick to the car, which he originally chose, although he doesn't know it, or pick the other possibility, the red goat. So here, if he switches, he also loses, because he picks the red goat, which is the other curtain. Now, let's look at the third possibility. In the third possibility, the player chooses the red goat. He doesn't know this, but he chooses the red goat. Then the host decides to reveal the green goat. What's left for us is the car. Since the player started with the red goat, and the green goat is already revealed, the choice that he can switch to is the car. And if he switches to the car, he wins because he gets it. Now for the last possibility. Here, the player chooses the green goat. The green goat is hidden behind curtain A. Then, the host reveals the red goat. So what's left for us again is the car. Since the player started with choosing the green goat, although he didn't to find out if it's better for the player to switch or not to switch. So now the probability of this happening is, first of all, what's hidden behind curtain A is a car. Now, as we saw here, the probability of that is 1/3. So we have 1/3. And then what happens next is, in this possibility, the host reveals the red goat. He does this with probability 1/2, as we saw here. So 1/3 times 1/2 is 1/6, which is the probability of this occurring. Now for our second possibility. Here, what's hidden behind curtain A is also a car. And like I said, the probability of it being the car is 1/3. So we have 1/3. And then the probability of the host revealing the green goat is 1/2. Like I said before, there's the red goat and the green goat, and so choosing the green goat, he does this with probability 1/2. So we multiply by 1/2 to get 1/6, which is the probability of this incident occurring. Now let's find the probability of the third incident occurring. This means that what's hidden behind curtain A is the red goat. Now, this happens with probability 1/3, as we found here. So we have 1/3, and then the host reveals the green goat. This happens with probability 1, because there's only one goat to choose from. So 1/3 multiplied by 1 equals 1/3. Now we are to find the probability of the final incident occurring. Here, what's hidden behind curtain A is the green goat. And this also happens with probability 1/3, as shown here. Then, the host reveals a red goat. The probability of this happening is 1, because there's only one other goat to choose from. So 1/3 multiplied by 1 equals 1/3, which is the probability of this incident occurring. So now we see that there are two cases where switching causes the player to lose, and two cases where switching causes the player to win. The combined probability for losing is 1/3. 1/6 plus 1/6. The combined probability for the player winning if he switches is 2/3, which is 1/3 plus 1/3. So now we see here that if the player switches from his original decision, he wins with probability 2/3. And if he doesn't switch, then he has probability 1/3 of winning. Or that means that if he does switch, he has probability 1/3 of losing. So here we see that it's obviously the right decision to switch. And in mathematics, sometimes nothing is what it seems.